So, what if you could have an AI that could work on a single problem, say curing a disease, not just for a day or a week, but for years with a completely unwavering focus? I know, it sounds like something straight out of science fiction. But the hardware to do it, it's already here. So, let's dive into a really fascinating design that could make this kind of relentless concentration a reality.
And look, the groundwork is already being laid. We're talking about these incredible machines like the NVIDIA DGX Spar. It's literally an AI supercomputer that can sit right on your desk. These things can run massive, 200 billion parameter models right in your office. The power is becoming insanely accessible.
And these machines, they've got some serious short-term memory, what we all call the context window. We're talking about the ability to process a million tokens at once. That's a huge amount of information for an AI to hold in its mind at any single moment. But here's the real question, right? Even a million tokens, which is, the equivalent of a very long book, it's just not enough when your project timeline is measured in months or even years. How does an AI keep a continuous train of thought over that kind of timescale? How does it not forget some crucial detail from last week or even last year? And that right there is the big hurdle for creating truly autonomous, long-running agents. That finite context window is a serious bottleneck. If we want to build an AI that can actually tackle humanity's grand challenges, we have to engineer a way for it to remember and recall and manage knowledge that goes way beyond what can fit in its active memory. So how do we get around this? Well, let's take a look at this really elegant concept from a design by Anthony Mack. It's called the context pyramid. Just think of it as a specialized long-term memory system for the AI, a hierarchical one dedicated to just a single subject or project. Okay, so let's break this down to make it super concrete. Imagine it's for a software project. At the very bottom, you've got the raw token layer. This is the actual code, all the JavaScript, CSS, the whole shebang. You go up a level, you get the summary layer. So your design docs, function descriptions, that kind of stuff. Above that, an overview, kind of like an executive summary. And right at the very tip top, the essence. Just a title, like Web App V1. It's just a simple pointer to everything below it. And this is where it gets really brilliant, especially for any of you with a graphics or game dev background. The bitmap analogy is just perfect. Just like how textures in a game are pre-rendered at different resolutions for super fast loading, the information in the pyramid is already structured. The AI doesn't have to waste time and compute trying to summarize things on the fly. It can just instantly grab the exact level of detail it needs. It's incredibly efficient. All right, so we've got the long-term memory structure down. But how does an AI agent actually use these pyramids to think and stay productive? Let's walk through a typical day in its life, this sort of dynamic daily cycle. So, at any given moment, if you could peek inside the AI's mind, its active context window, you'd see these four parts. There's the soul, which is like its DNA, its core instructions that never change. Then you have the executive. That's the project manager keeping track of the to-do list. Then the pyramid contexts, which is the crucial memory it pulls from long-term storage. And finally, the working context. That's its scratch pad for all its new ideas. The whole cycle kicks off each morning. The executive function, the manager, takes a look at the to-do list and figures out exactly what knowledge is needed for the day. And it's smart about it. It might pull in the high-level overview of Project A, but then grab the super detailed raw code from a specific library in Project B. It literally assembles its mind for the day's work. And then, it just gets to work. All day, the AI is thinking, coding, analyzing, reasoning. And every new discovery, every single line of code it writes, every little insight it generates, all of that stuff gets dumped into that temporary scratch pad, the working context. This is the messy workbench where all the active problem-solving happens. And here is the most crucial part. At the end of the day, the agent sleeps. And during this downtime, it processes everything it did that day. It filters through that messy working context, figures out what's actually valuable, and integrates this new hard-won knowledge back into the permanent context pyramids. It's literally updating its long-term understanding. This is how it truly learns and remembers. So this daily cycle means the memory system isn't just a static database. It's a living, evolving structure. So if we zoom out from this daily grind, you can see how this process of nightly compression allows the AI's knowledge to adapt and grow over months and even years. But wait, if the pyramids have a fixed size, how do they not just overflow? Well, it's got two clever tricks up its sleeve. The first is distillation. That's when it summarizes information, turning a bunch of detailed facts into higher-level concepts to save space. But sometimes you can't summarize without losing critical detail. And that's when it uses the second trick, splitting. It just carves off a big subtopic and gives it its own brand new pyramid. So what you end up with is this incredibly dynamic, living, breathing knowledge base. New information is constantly being added to the bottom. And get this, if the agent learns that something it knew before was wrong, it can actually go back and correct or even delete the old inaccurate data. And if two small topics start to look really related, it can just merge them into a single, more efficient pyramid. The whole system is designed for constant self-improvement. Okay, so why does all this complex architecture really matter? What's the end game here? What's the ultimate goal of building an AI that can remember and learn in such a sophisticated way? Well, it's about enabling it to do something that we humans, frankly, just can't. The payoff is relentless focus. This entire system is engineered to allow an AI to hammer away at a single, monumental problem for longer than any human or any team of humans ever could. It never gets tired, it never gets distracted, and it never ever forgets a key insight it had 5 years ago. So what kind of problems are we talking about here? I mean, think about the really big ones, the grand challenges. In medicine, it could be tirelessly searching for a cure for cancer. In physics, it could be analyzing petabytes of data for decades to uncover new fundamental laws. In engineering, it could be designing infrastructure on a planetary scale. These are the kinds of moonshots that this type of focus could unlock. So I'll just leave you with this question to chew on. Once we finally build an AI that can truly maintain a focused train of thought for not just a day, but for a decade or more, what seemingly impossible problems do you think it's going to solve first? The possibilities they're just staggering to think about.